In the last session, we have discussed the differential equation. We introduced what is a differential equation, and we sorted out what is dependent and independent variable. And we also found in the last session we have discussed differential equations in the linear form, and we introduced what is boundary condition, how boundary conditions can be applied to the differential equations and all. Now, we would like to discuss a particular type of differential equation, variable separable differential equation. That is a core content of this lecture. And before going to the variable separable form, we would like to go to another area, which is if you are given a family of curves, how to form differential equations out of it. Okay, forming differential equations of a given family of curves. Okay, you are given a set of curves or family of curves, and you have to form the differential equation corresponding to that family. So what you are given? You are given a family of curves. So what you have to do? Once you are given that equation representing family of curve, you have to differentiate it. And eliminate all the possible constants. That family of curve may containing some constant, you have to eliminate that constant. Okay, you can either substitute or through differentiation that constant may vanish. In some manner you can eliminate it. And once you eliminate that constants, we can construct the differential equation. Okay, that will be ready. So differentiate and eliminate the constant. That is a major part we have to focus on. So one thing you have to note here, that the order of the differential equation you get from a family of curve is equal to number of possible constants containing in that family. Okay, once again, order of differential equation representing a family of curves. Is same as the number of arbitrary constants present in the equation. Corresponding to the curve. So if you have one constant, once you differentiate and eliminate that constant, you get first order differential equation. If you have two constants, you will have second order differential equations. So number of constants equal to order of the differential equation corresponding to that family. Okay. Differential family, some curves in a represent equation differentiate and the constant eliminate the differential equation തന്നിരിക്കുന്ന കർവിന് കറസ്പോണ്ടിങ് ആയിട്ടുള്ള ഡിഫറൻഷ്യൽ ഇക്വേഷൻ. അപ്പോൾ അതിന്റെ ഓർഡർ എങ്ങനെ ആദ്യമേ മനസ്സിലാക്കാം? ചിലപ്പോൾ നിങ്ങൾക്ക് ഒരു ഒബ്ജക്റ്റീവ് എക്സാമിന് ഒരു ക്വസ്റ്റ്യൻ കാണും. യു ആർ ഗിവൺ എ കർവ്, വാട്ട് ഈസ് ദി ഓർഡർ ഓഫ് ദ ഡിഫറൻഷ്യൽ ഇക്വേഷൻ? ആദ്യം നോക്കേണ്ടത് ആ കർവിൽ എത്ര കോൺസ്റ്റന്റ് ഉണ്ടെന്നാണ്. രണ്ട് കോൺസ്റ്റന്റ് ഉണ്ടെങ്കിൽ സെക്കൻഡ് ഓർഡർ ഡിഫറൻഷ്യൽ ഇക്വേഷൻ ആയിരിക്കും. ഓപ്ഷനിൽ സെക്കൻഡ് ഓർഡർ മാത്രമേ ഉള്ളെങ്കിൽ അത് കുത്തുക, ചെയ്യാൻ പോണ്ട. സോ നമുക്ക് കുറച്ച് പ്രോബ്ലംസ് ചെയ്ത് അത് മനസ്സിലാക്കാം. ഓക്കെ, questions. Form differential equations representing family of curves given below. Okay, so first family is y equal to mx. So you know this is the family of straight line, right? Straight line family of straight lines with different slopes. M can take any value, so it represents a family, not just a number. So m equal to 1, y equal to x, a single curve. Okay, now it represents a family. So we want to find the differential equation corresponding to this family of curves. So what do you have to do? Differentiate it. So dy equal to m dx, or your dy by dx equal to m. Now you can, your m is ready. Now you can replace m, and y equal to mx, y equal to m is dy by dx into x, which implies x into dy by dx minus y equal to 0. That is x y prime minus y equal to 0. This is the differential equation corresponding to this family. Okay, now differentiating, through differentiation we can eliminate this constant, right? Okay, so we have one more example. Second one, the curve is given which is y equal to a sine x plus b. You can see that a and b are constants, so the corresponding curve will be a second order differential equation. Listen, so first I am differentiating this y prime equal to a sin x upon derivative, you get cos x plus b. Okay, x plus b derivative is 1 just, and y double prime equal to a cos x plus b derivative minus sin x plus b. So we can solve this together. Y double prime equal to minus, I am taking a sin x plus b. So this is actually very simple actually. Why? Because this is nothing but our y. So I get y double prime equal to minus y, or this is just y double prime plus y equal to 0. So this is the differential equation corresponding to that set of family. Okay, so we are very lucky to have such a question. Now next one, third question we can do here. X square by a square plus y square by b square equal to 1. You know this is representing an ellipse, right? The semi-major axis is a and the semi-minor axis is b. So this represent an ellipse which is centered at the origin. Okay, so we have two constants a and b here, therefore it will be a differential equation of order 2. So we just differentiate it. For instance, so differentiation gives you x square differentiation 2x, a square will become under into dx plus 2y by b square dy equal to 1 differentiation, you get 0. Okay, we can rearrange it. 2x by a square dx equal to minus 2y by b square dy. So I can write dy by dx. Okay, dy by dx into y. Here I have y and I bring x here. Y by x will be equal to, the 2's will cancel, and I put b here, which is minus b square by a square. So I am left with this quantity. That equation I will write it again, right here again. Y by x dy by dx equal to minus b square upon a square. Okay, so one more differentiation will cancel this constant, right? So I am differentiating one more time. So be careful, here we have a product. Okay, now we are differentiating with respect to x. Therefore, first function into differential of the second, that is d square y by dx square, be very careful, plus the second function into dy by dx into derivative of first with respect to x. Now you have y by x, you have to take the derivative with respect to x. So we have to apply the quotient rule for y and x, right? So denominator into derivative of numerator minus numerator into derivative of denominator x is 1 divided by denominator is x, which square, equal to, on the right hand side, upon taking the derivative you get 0, right? So what the constants are removed. Now your answer is ready, right? Y by x, d square y by dx square, plus, be very careful, you have dy by dx and dy by dx here. So x and 1x will cancel, therefore 1 by x dy by dx whole square minus y by x square dy by dx. This is equal to 0. Now you can just multiply with this x square here. So x multiply with x square, that will gives you xy d square y by dx square, plus multiplying with x square, bring an x here, x dy by dx. That is not necessary to get some symmetry. Say, to get rid of this 1 by x square, I am doing it. That's not necessary. Okay. So y dy by dx equal to 0. This is the differential equation of the ellipse which is centered at the origin. I hope you may get that idea. Okay. So if I give a curve to you, you are now capable of finding the curve corresponding to the family, right? So I am giving the next question, y square equal to 4ax. What does it represent? Y square equal to 4ax is actually, it represent a parabola, right? Parabola. Family of parabola, right? So something like this. So we want to find the differential equation for this parabola. So just to differentiate this, 2y dy equal to 4a dx, or dy by dx equal to, okay, I need to replace 4a. So I am just keeping that 4a as it is, and this is 4a, right? So I am taking that expression again, y square equal to 4a into x, y square equal to 4a is nothing but 2y dy by dx into x. So that will be our solution. So y square minus 2xy dy by dx equal to 0. This represents differential equation of the parabola. Okay, once you solve the differential equation back, we will get the solution. So now we are capable of doing or developing a differential equation from a given equation, and also we know once a differential equation is given, we can find the solution. Both things we know. But some differential equations we cannot solve simply. We have to choose a definite path to arrive the solution. Okay. So there are different forms are introduced. The first very important form of differential equation is variable separable form. Variable separable form. Okay. What is variable separable form? Suppose you are given a differential equation y prime, which is nothing but dy by dx equal to some function f of x. So in such a case, if you see, you can easily separate the variable. This is a function of x only. So f of x into dx. This is function of x only. Okay. Now this term on the left hand side containing y, and now this function containing x only. On the right hand side we have functions of x. So just integrate dy equal to integral f of x dx. That gives you y equal to integral f of x dx plus c. This is the solution of the differential equation. Once you have variable separable form, differential equation in the form of variable separable, if the variables can be separated, just to separate the variable, do integration straightforward. Okay, this is very important for a physicist point of view, because many equations we come across in physics are variable separable form. So we will look very detailed into this variable separable form. So before doing some physical example, I would like to do some mathematical questions. So first one here, say x y prime equal to y plus 1. Okay. So at a first look, x dy by dx, okay, this is equal to y plus 1. This is fine. I can bring that y plus 1 here. This is good. And dx, I can bring this x down here. Now if you see, the variables are separated out. Now you can just go for integration, right? Straightforward integration. So this is just log of y plus 1. This is log of x plus integration constant. I am introducing log c. So this is just log cx. I'm sorry, log cx. So both sides we have log. Take the exponential, I get y plus 1 equal to cx. This is the solution of the differential equation. What is it? What does it represent actually? Y equal to mx plus c form, right? So this represents family of curves or straight line. Curves is general, okay, in xy plane. Actually, it represents straight line. Curve is more general. So for every c, we will get different curves, right? Say c equal to 1, y plus 1 equal to x, one curve. C equal to 2, we get another curve. C equal to 3, we get another curve. So this represents family. Keep in mind, if you have a constant, then that equation will represent some family, not a particular curve. That will be family of curves. Okay. Now we can move on to next example, which is of course from physics. I think we can do it from physics. Wait, we have simple example. I will do. Yes. Question. Dy by dx equal to 1 plus y square divided by 1 plus x square. Okay. So if you see here, dy plus divided by 1 plus y square, I am bringing this here, and dx by 1 plus x square. Now these variables are separated, just integration. That will take, oh, I'm sorry, this is not log. What is the integral of 1 by 1 plus x square dx? That will be tan inverse of x. So if it is a square, 1 by a, tan inverse of x by a, right? So now this is just a tan inverse of x. So here y, here we have y, therefore tan inverse of y equal to here tan inverse of x plus some arbitrary constant. So this is enough. This is a solution of this particular differential equation. Okay. So one more problem. Dy by dx equal to minus 4x y square and y of 0 equal to 1. So here one of the boundary conditions also given. You have seen that while solving this differential equation, the first order, we get one constant. So using this boundary condition, we can eliminate that constant. Okay, so we can solve now. Our equation is dy by dx equal to minus 4xy square. So dy, take the y terms on side, y square equal to minus 4x dx. Right? So 1 by y square upon integration, that become minus 1 by y, right? This will be equal to minus 4x square by 2. Therefore, that is 2x square plus c. Now, what is the meaning of that boundary condition? Y of 0 equal to 1. What does it mean? Y of 0 equal to 1 means actually y of x is equal to something. As x is equal to 0, the value of y is 1. This is the meaning of this equation. If you put x equal to 0, your y will be 1. Then if you substitute minus 1 by y is equal to 1 when your x is equal to 0, that gives you your constant is equal to minus 1. So our final solution will be minus 1 by y equal to minus 2x square minus 1. So if you take the minus outside and the cancel with here, and I get y equal to 1 by 2x square plus 1. This is the final solution of our differential equation. Okay. One more question I will do. Next question. The differential equation of the curve. Okay, I'm sorry. The differential equation of the curve passing through the point 1 1. I'm sorry. We want to find the equation. The equation of the curve passing through the point 1 1, whose differential equation is x dy equal to 2x square plus 1 dx, where x not equal to 0. That is, you are given a differential equation, and once you solve, you get a curve. That curve passing through this point. Why it is given? This is actually a boundary condition. Finally, you will get a constant while solving this differential equation. We are looking for a particular solution. The differential equation of a curve, one curve is passing through this point. This point വഴി പോകുന്ന കർവിന്റെ ഡിഫറൻഷ്യൽ ഇക്വേഷൻ ആണ് നമുക്ക് വേണ്ടത്. അപ്പോൾ ആ കോൺസ്റ്റന്റിനെ നമ്മൾ ഈ ബൗണ്ടറി കണ്ടീഷൻ വെച്ചിട്ട് എലിമിനേറ്റ് ചെയ്ത് കളയണം. ഓക്കെ, നമുക്ക് സ്റ്റാർട്ട് ചെയ്യാം. So we can start x dy equal to 2x square plus 1 dx, right? So dy by dx equal to 2x square plus 1 divided by x. So this is nothing but 2x plus 1 by x. I'm dividing with x on this side. So what I get? Dy equal to 2x plus 1 by x dx. Okay, so now variables are separated. You can just integrate. That will gives you y equal to x square by 2, 2 will cancel, plus log x plus some constant c. Okay, now this is the curve, and one more condition is given, that curve is passing through the point 0 0, right? I'm sorry, that passing through the point 1 1, which means as the value x equal to 1, that curve passing through the y value should be 1. So if you substitute this condition here, the y value is 1 when x equal to 1 equal to ln 1 plus c. So 1 equal to 1, ln 1 is 0 plus c. That implies you c equal to 0, and you are left with the solution y equal to x square plus ln x. So this is the required curve. Okay. So one more physical example, one more mathematical question I will give you. Next question. The equation of the curve, passing through the point minus 2 3 and slope of the tangent to the curve at point xy, arbitrary point, is 2x by y is dash. We have to find equation of a curve, some y equal to something. That curve passing through this point. And also the slope of the tangent to the curve at a point is given by this. Okay, so we need some idea for this. Suppose you have a curve which is in xy plane, say x and y. Then the slope, this is the tangent to the curve, and slope of tangent to the curve. Slope of tangent to the curve, that will be equal to dy by dx. So if you have y equal to f of x, then slope of the tangent to the curve is given by this. Okay. What is the slope of the normal? Negative of the slope of the tangent will be negative of the reciprocal of the slope of the tangent will be slope of normal. Okay, anyway, I'll leave that. We now need slope of the tangent idea. Now slope of the tangent is dy by dx, which is given. Slope of the tangent to the curve is 2x by y, which is given. Now this is variable separable form. So y dy equal to 2x dx, right? So on integration, we get y square by 2 equal to 2x square by 2, that is x square, plus some constant c. Okay. Oh, I'm sorry, in this question, this is 2x by y square, not just y. Okay, y square. So upon integration, I get y cube by 3. Sorry for that. I will write. Okay, that's fine. Y cube by 3. So now we can use the condition. This curve is passing through the point 2 minus 3, which means as you put x equal to 2, your y value is minus 3. So if you substitute, I'm sorry, this passed to the point minus 2 plus 3, reversed. So x equal to minus 2, your y equal to plus 3. Right, I think you're writing that way. Yes. So if you substitute here, you have y equal to 3. So 3 cube by 3 equal to x square, that is minus 2 square plus c, that is 9 equal to 4 plus c, that gives you c equal to 5. Your c is 5. Then your final solution is y cube by 3 equal to x square plus 5, that is y cube equal to 3x square plus 15. If you take 3 here, and your y will be 3x square plus 15 whole power 1 by 3. This is the final solution to the curve. Okay, these kind of questions can be asked from the idea of variable separable differential equation. Now I bring your attention to some physical concept. Okay, so first one, I would like to introduce a phenomenon called radioactive decay. Radioactive decay. Okay. Suppose you have some radioactive element at a time t equal to 0. There are n0 radioactive elements. You know, since it is radioactive, from the nucleus, the active particles like alpha particle, gamma particle, beta particle, they will emit it. And as time being, this n0 will disintegrate at arbitrary time t equal to t. The number of active nuclei will be n. Initially, there are n not active nuclei. As time progresses, this nuclei goes on disintegration. They will emit particles like alpha, beta, and all, which means the active number of nuclei decreases. Okay, some nuclei go to the stable state, and n is remaining at some arbitrary time t. So the radioactive rate law says that the rate of disintegration at an instant time t is proportional to number of the active element present at that time. Okay, This is a physical concept. Rate of disintegration of the active nuclei is proportional to number of active elements present at that time. Here you can see as time goes on, the number decreases. Therefore, I am introducing a negative sign. Therefore, dn by dt, I could introduce a constant here, say lambda n. I am bringing this negative term here. Okay, now dn by n equal to minus lambda dt. Variables are separated and we can integrate. Now the conditions are given, so we can directly put this into here. Initially we have n number of particles, now that is become n, right? And now initially time t equal to 0, now the time is t. So if you integrate ln n from the limit n0 to n equal to minus lambda t from the limit 0 to t, right? So ln n by n0 equal to minus lambda t, and if you take the exponential, n equal to n0 e raised to minus lambda t. This is radioactive disintegration law, and this result is obtained by using this first order variable separable differential equation. Okay, so instead of giving this limit, we can also do without limit. That will introduce a constant. That constant can be eliminated by using this condition. Okay, that is also you can do. Since it is given, I assume it initially, I put the limit according to this. Okay. Then another important, very, very important equation for a physicist, which is Schrodinger equation. Schrodinger's equation. Okay. We will just tell the mathematics now. Say IH cross time dependent Schrodinger equation. IH cross dou by dou t of psi equal to, this is nothing but the operator E psi. Okay. We will discuss these equations in quantum mechanics thoroughly. Okay, now we are going to take IH cross here, dou psi by psi, which is equal to E dou t. Since it depends only on t, we can replace it with the perfect differential. So IH cross d psi by psi with equal to E integral dt. Okay. So upon integration, you get ln psi equal to Et. I will bring that IH cross term here, which is IH cross. Okay. So this is nothing but minus I E t by H cross. I goes up, it will minus I E t, right? Now, okay, I forgot to take a constant, so I will wipe it. You probably ask for it. So minus I E t by H cross plus some constant term C. Okay. Now, this constant have to be removed. I am making an assumption. I am making at a t equal to 0, let the state vector psi equal to psi naught. This is my assumption. Then what happened? Ln psi naught equal to t equal to 0. This time is 0, and the constant becomes c. So I get ln psi equal to minus I E t by H cross plus ln psi naught. So ln psi, this psi naught will come here by psi naught equal to I minus I E t by H cross. So this taking the exponential, you get psi equal to psi naught e raised to minus I E t by H cross. The physical meaning of this equation will tell you later, because we are not yet introduced the quantum mechanics. So just a mathematical equation, you just understand that only. Anyway, I will spend 1 minute on this. Quantum mechanically, if you having a state vector, okay, your state is psi naught. If it is given, using this operator, e raised to minus I et by h cross. This is called a time translation operator. You can take the system to a new state psi. You see, the operator acting on psi will take you to a new state. So this is a quantum mechanical operator, and this is called a time translation operator in quantum mechanics. So this is a Schrodinger equation solution. See, this is also solved using the variable separable method, right? Okay. Now, next one, finding the family of curve. Finding family of curves and orthogonal families. Okay, see. Say you have a differential equation, say dy by dx equal to minus x by y. We can solve this one using the variable suppression method. Dy into y into dy equal to minus x dx. Upon integration, you get y square by 2 plus x square by 2 equal to some constant, that is x square plus y square equal to root 2 c whole square. Okay, I can write like this. What does it represent? This represents family of circles. Family of circles with origin at 0, 0. What is the radius? We cannot say. The radius value will depends on c. So this will represent family of concentric circles, right? Something like this, because their origin are at origins are all, the origins of all the circles at 0, 0. So the presence of c make it the family of circles. Suppose you take c equal to 1, then this represent, say c equal to 1, then it represent a circle x square plus y square equal to root 2 square. A circle with radius root 2 whose origin is at 0, 0. Before putting the value, we can only say that this represent a family of circles. Okay. So I will give one more question to understand the family of curves. Say dy by dx equal to y by x. We can solve this. Dy by y equal to dx by x. Variables are separated now. Now you can easily integrate this. Integral. Then ln y equal to ln x. Plus both are log, we can use a constant which is also log. If you use another constant, no problem. If boundary condition is given, if you substitute that boundary condition here, you will get that constant as log. For example, I'm sorry. Here you can see in the Schrodinger's equation, you can see here a log term come, right? A log term come. But I use the constant as c only. You can use as log c also, no problem, because it's a constant. Even though I use c as a constant, upon applying the boundary condition, that constant turn out to be log. No problem. So you can use either c or log c. Upon applying the boundary condition, you will get the same constant. Since it is a constant, it's not a problem. But here no boundary conditions are given, so mathematically it is easy for me to solve if I use a log as a constant. So log c. Okay. So y equal to, I'm sorry for that, log y equal to ln cx, log a plus log b, right? So exponentiating y equal to cx. What is represented by this equation? This is a straight line, but c make it family of straight line. Family of straight lines. C is different, means slope is different. Okay, so if I draw that is passing through the origin, right? Y equal to x. So x equal to 0, your y should be 0. So all the straight lines are passing through the origin. So these are represented by y equal to cx, x and y here, right? Family of straight line passing through origin. Okay. Now, one more car I will give you. Third one, say dy by dx equal to some x by y. Okay. Now, if you take this y dy equal to x dx, now y square by 2 minus x square by 2 equal to 0, right? I'm sorry, this there will be constant of integration equal to c. So what does it represent? Y square minus x square form means is a hyperbola. Family of hyperbola. Symmetric about the y-axis. So y square minus x square come. Okay. So by solving a given differential equation, we can find such a family of curves. I hope the idea is clear for you. If you are given a curve, just simplify it, and the solution will be something y equal to x form, and that will represent a family of curve. Okay. Now, by keeping this idea in mind, we can move to a new concept which is important in the exam point of view also, which is orthogonal family of curves. Orthogonal family of curves. So what is the condition for orthogonality of two curves? Suppose you have two curves, say whose at a given point his slope is m1, and say this is an example. This is not the actual situation. Say another curve, this is having slope m2. Then the condition for orthogonality condition is that the product of the slope equal to -1. What is the slope? Slope of a curve, we already mentioned, slope of a curve is dy by dx. Okay. So how we can find the orthogonal families? Okay. First, in the questions, you will give a curve. A curve will be given. You want to find the orthogonal family corresponding to this curve. What do you have to do? You have to do the differentiation. Differentiate and find slope. You have to find the slope first. Slope of the given curve. And we know that if there is some constant, you can eliminate that constant also. Okay. During this process, and eliminate constant, if any. Okay, if any constants are there, you can eliminate it also. And I'm sorry for this. Okay. Now, what do you have to do? You are given a curve, you first differentiate it, and you found slope. And we know that m1 into m2 equal to -1, which means dy by dx, slope of the given curve into slope of the curve which is orthogonal. Slope of orthogonal curve, that product will take you -1. This is equal to -1 only if dy by dx given is orthogonal to this. So the slope of orthogonal curve, will be equal to minus dy by dx of slope of the given curve. Okay, so you get a differential equation from this, and you can solve for this, and you can find y of orthogonal equal to something. Okay, so idea is this one: your curve will be given, you have to differentiate. If there is any constant, you have to eliminate those constant, then find the slope of the given curve into slope of the orthogonal family. That product term will give you -1. Therefore, slope of the orthogonal family will be -1 by dou x, or slope of the given curve. So this is the idea we are using to find out the orthogonal family. Okay, you will be given a curve, you have to find corresponding orthogonal family. Okay, that idea will be clear to you if we do some question. Wait, say find the orthogonal families of curves corresponding to given family of curves. നിങ്ങൾക്ക് തന്നിരിക്കുന്നത് ഒരു ഫാമിലി ഓഫ് കർവ് ആണ്, അതിന് കറസ്പോണ്ടിങ് ആയിട്ടുള്ള ഓർത്തോഗണൽ ഫാമിലി ഏതാണെന്ന് കണ്ടുപിടിക്കണം. ഓക്കെ, സോ ഫസ്റ്റ് ക്വസ്റ്റ്യൻ, the first one is x square plus y square equal to c square. Okay, what is actually this represent? What is it? Circle, right? Circle with center at origin. Better to write family of circles, family of concentric circles whose center is at origin. So first we have to differentiate. So 2x dx plus 2y dy, upon differentiation that constant is eliminated, right? So the slope of the given curve, means circle, given curve, which is dy by dx. If you take dy by dx, what do you get? Minus x by y, right? If you bring this term first here and rearranging, you get minus x by y, right? So this is slope of the given curve. We are required to find the required to find the equation of the orthogonal curve. Okay, so we have this idea, slope of given into slope of orthogonal curve equal to -1. Therefore, slope of orthogonal curve will be equal to -1 by slope of given. Orthogonal curve having the slope dy by dx is equal to -1 by slope of the given curve. This is minus x by y. This is upon solving y by x, right? So dy by dx, this is slope of orthogonal curve, keep in mind, equal to y by x. So once you solve, you get equation of the orthogonal curve. So you get dy by y equal to dx by x. So upon integration, you get ln y equal to ln x plus ln c. So y equal to cx, which means family of straight lines, right? Family of straight lines. So our conclusion is this: if you have a family of circles, family of circles whose origin is at a center, Okay. The orthogonal family corresponding to these circles are straight lines. If you see at this point, they are perpendicular. Orthogonal family of this circles are straight lines passing through the center. The slope can be negative, no problem. It's a constant. So circles and straight lines are orthogonal families. Okay. Straight lines are orthogonal families of the circles. That's it. Now, I hope now you have the idea how to find the orthogonal family. Okay. So one more question I will do. Find orthogonal family. Find orthogonal family of curves corresponding to y equal to cx. In the reverse way. ഉറപ്പായിട്ട് എന്ത് കിട്ടണം നമുക്ക് സർക്കിൾ കിട്ടണം ഓക്കെ നമുക്കൊന്ന് ചെയ്തു നോക്കാം so we are given y equal to cx, therefore dy by dx equal to c. Now using this equation we can eliminate this constant y equal to dy by dx into x. So finally I get dy by dx equal to y by x. What is this represent? Slope of the given, the slope of the given curve. Slope of orthogonal family equal to -1 by slope of given curve, right? So that is equal to -1 by slope of given curve is y by x. Therefore dy by dx equal to, if you rearrange you get x by y. So upon variable separating, y dy equal to -x dx. On integration you get y square by 2 equal to -x square by 2 plus some constant, that is x square plus y square equal to √2c whole square. Okay. So the orthogonal family, so this represents circle. So if you have some straight line, the corresponding orthogonal family is circle. In the previous problem you have seen, if you have some circle, the corresponding orthogonal family will be a straight line. Okay, never mind this constant. √2 is also a constant. You may probably think in the last problem we have only c square. Now it is √c square. Not a problem because it's a constant. Okay. So the idea is that circles and straight lines are orthogonal families each other. They are orthogonal to each other. Okay. So one more physical concept I will discuss using this variable separable method, which is Newton's law of cooling. Newton's law of cooling. We will see in thermodynamics about this. The law says this: suppose you have a hot body, okay, it is at a temperature T, maintained at some temperature T, and the surroundings having temperature T naught. And we know that heat is always flows from, heat to flow is always from hot body to cold body. Okay, so if the temperature of the body is higher than the surrounding, the heat energy will flow to the surrounding. Eventually the temperature of the body goes on decrease. Once the temperature of the body becomes equal to the surrounding temperature, it is called thermal equilibrium. Then no more heat will flow from the body to the surroundings. Okay. If T is less than T naught, then heat will flow to the body from the surrounding. If we place some bottle or pot in the stove, the flame energy, the heat energy is high there. Therefore, heat will flow from the fire to our pot and it get hotter. Okay, we can see that. So the reverse also happen, which also depends on the temperature. The point is that depending upon the nature of the temperature of the body and the surrounding, heat can flow from body to surrounding or vice versa. Okay, depending on the temperature, which body is hotter, the heat always flows from hot body to cold body. Keep in mind. Okay, the Newton's law of cooling says that the rate of heat loss dT by dt, rate of decay of temperature is directly proportional to temperature difference between the body and the surrounding. Okay, it's decay, therefore I am putting a negative sign. The rate of decay of temperature is directly proportional to temperature difference between the body and the surrounding. Okay, this is Newton's law of cooling, and you can see that we can variably separate it. Okay, suppose initially the body having some temperature Ti. Okay, I am taking the body here again. Initially body having temperature Ti and the surrounding temperature is T0, and heat is, and this is a condition Ti greater than T0, heat will flow from the body to the surroundings, and after some time the temperature of the body will fall to Tf because heat flows out. Now I would like to integrate this dt divided by T by T0, dt upon T by T0 equal to just dt. So at a time t equal to T0, sorry, at time t equal to 0, the body having temperature Ti, t equal to 0, the temperature of the body is Ti. At t equal to t, arbitrary time, the temperature of the body is Tf. This is the boundary condition we are going to use. Okay, so what I get? Okay, I will write it again, dt upon T by T0. I think I miss a negative somewhere. Yes, here a negative sign here. So I am putting here, okay. This is equal to, I am also introducing some constant. This is proportional, so I am introducing some constant k. Let it be. So minus k dt. So on integration, initial temperature is Ti and final temperature is Tf. Initial time 0, final time t. Then you will get log T minus T0 from T initial to T final equal to k T 0 to T. So that will gives you ln Tf minus Ti minus ln T initial minus Ti equal to minus k T. So minus I am missing again, right? So the final expression log T final minus T initial divided by something wrong. T final minus T0, because it is T0, it's a constant. T0 divided by T initial minus T0 equal to minus KT. Okay, you can write this expression by taking this term as positive. You can bring this negative and reverse this log. That is not required. So if you want, you can do that. To get rid of the negative sign, you can write this expression like this also. ln Ti minus T0 divided by Tf minus T0, okay, equal to KT. Now this negative will be cancelled out. So this is Newton's law of cooling. Always keep in mind what is Ti, initial temperature of the body, what is Tf, final temperature of the body. T0 is the temperature of the surrounding. Okay. So I would like to conclude this session with the one question. Okay, the question is that, okay, I will write the question. A cup of tea at 100 degrees Celsius, it is maintained at 100 degrees Celsius, is placed on a table. Okay, where the room temperature is 20 degree. Room temperature is 20 degrees Celsius. It takes 5 minutes to cool to 60 degrees Celsius. From 100 degree to 60 degree, it will take 5 minutes. Then the question is, how long it will take? How long it will take to cool to 30 degrees Celsius? So, since we are familiar with this equation, we can use it directly. Okay. So, condition is this. Initially, tea is here, a cup of tea is here. It is placed on the table. I am very poor at drawing. Please adjust. This is cup of tea. Okay. So, initially, the temperature is 100 degrees Celsius. After 5 minutes, cup of tea is here. Okay. Now the temperature is 60 degree after 5 minutes. The question is, how much time will take if its temperature fall to 30 degree? From 100 degree to 30 degree, how much time it will take? This is the question. Okay. Now we have our equation, log T initial minus T surrounding divided by T final minus T surrounding equal to K into T, right? So we can, we have a problem because there is a constant. So we need at least 2 equations to eliminate that, because we need a solution time equal to something. So we need 2 equations. So first case, I am considering the case, the temperature changes from 100 to 60 degree. In that case, initial temperature is 100, final temperature is 60 degree, surrounding temperature is 20 degree. So the quantities Ti minus T naught will be 100 minus 20 will be 80, and T final minus T naught will be 60 minus 20 will be 40. And if I substitute in this equation, I will get ln 80 by 40 equal to kt, right? So this is ln 2 equal to k. What is time? 5. So 5k. This is equation 1. This is equation 1 because it describes the first steps. Now I am going to consider this step. Okay. My initial temperature is 100. Final temperature is 30 degree. Okay. Surrounding temperature, no change, that is 20 degree only. So I am formulating Ti minus T naught is just 80 now also. And Tf minus T naught is, Tf is 30 now, right? So 30 minus 20 is 10. So if I substitute it in this equation, I will get log 80 by 10 equal to 5. What is the time taken? I don't know. That we have to find 5t. I'm sorry. That is kt, right? So kt equation 2. So not equation 2, I can solve this. ln 8 equal to kt. This is equation 2. You can solve 1 and 2. You can divide. You can solve it very straightforward. ln 8 equal to kt. ln 2 equal to kt. ln 2 equal to 5k. So I am dividing these 2 equations. So I can eliminate that constant term. So ln 8 I can write on as ln 2 raised to 3. This is nothing but 3 ln 2. Okay. So ln 8 is 3 ln 2. divided by ln2. Now I can cancel, equal to k get cancelled and t by 5. So this is cancelled and I get t equal to 5 into 3. This is nothing but 15 minutes. So it will take 15 minutes to cool down from a temperature of 100 degree to 30 degree. So if we take the diagram again, where is the diagram? So it will take, the first process will take 5 minutes. The second process will take more time, 10 minutes. Why? Because we already mentioned the law. The rate of degradation of temperature is proportional to temperature difference between the body and the surrounding. In this case, the temperature difference between the body and the surrounding is very less. Okay, initially that was to 80, now it is 40 only. So heat flows out of the body very slowly only. Okay. So that's all about the applications of our variable separable differential equations. And if you are interested, you can solve some question. I will give you some question as a homework. You can do, you can work it out. Okay. Some homework question. dy by dx plus 2y equal to 0. And y of 1 equal to 5, which means at x equal to 1, your y equal to 5. Okay. So if you solve, your solution will be y equal to 5 e raised to minus 2x plus 2. Okay, this is first homework. Then second, dy by dx equal to x square y and y of 0 equal to 1, which means at x equal to 0, your y equal to 1, and the solution will be, and the solution to this equation is y equal to e raised to x cube by 3. And one more question I will give you, dx by dt. Okay. Okay, this question I will solve for you. Okay, not too much homework. Plus kx square. A very simple question. And this x of 0 equal to a, which means at x equal to 0, I'm sorry. At t equal to 0, once you solve, you get x as a function of time, right? So at t equal to 0, your x equal to a. And the answer is x is equal to 1 upon kt plus 1 by a. Okay. Anyway, we will take only few minutes, right? You try to solve and I will also solve for you. Okay, every question I will solve. So first one, dy by dx plus 2y equal to 0. So if you separate dy by dx equal to minus 2y, so dy by y equal to minus 2 dx, taking the log integral, log y will be equal to minus 2x plus c. Okay, now you can see, use log c also, no problem. Okay. Now, if you put the boundary condition, what is the boundary condition? At x equal to 1, your y equal to 5, you will get ln 5 will be equal to minus 2 x equal to 1 plus c. So ln 5 plus 2 equal to your c. Okay, if you use log c, then log c equal to this, that will you get. That's it. So finally, ln y equal to minus 2x plus c is nothing but log 5 plus 2. So if you bring this log y here, ln y by 5, so this is minus 2x plus 2. So if you exponentiate this one, you will get y by 5 equal to e raised to minus 2x plus 2, right? So finally you get y equal to 5 e raised to minus 2x plus 2. So y equal to 5 e raised to minus 2x plus 2. This is the answer to the first question. Okay, now we'll go for the second. So the second question is a very simple one. Dy by dx equal to x square y with the condition y equal to 1 with x equal to 0. So this is dy by y equal to x square dx. So upon integration, you will get log y equal to x cube by 3 plus some constant. So if you substitute this condition, log 1 will be equal to 0 plus c, which means your constant c equal to 0. So you get ln y equal to x cube by 3. So y equal to e raised to x cube by 3. So that is the answer to the second question. And we will discuss our final question. The question is this: dx by dt plus kx square equal to 0. So dx by x square equal to minus k dt. Upon solving, you get, on integration, you get minus 1 by x equal to minus kt plus some constant c. What is the initial condition? At x equal to a, at t equal to 0, x equal to a. So minus 1 by a at t equal to 0 plus c. That gives you your constant is minus 1 by a. So substitute here, you have minus 1 by x equal to minus kt plus constant is minus 1 by a, right? So you can take that minus outside. So 1 by x will be equal to kt plus 1 by a, or your x of t is just 1 upon kt plus 1 by a. So this is the solution to our differential equation. Now we have concluded our discussion on variable separable method. We discussed that method, and we discussed some physical applications corresponding to the method, and there are some previous problems, and we will discuss those problems once all the methods are introduced. Okay, നമ്മൾ കുറേ previous problems ചെയ്യും, നമ്മുടെ എല്ലാ മെത്തേഡുകളും പറഞ്ഞതിന് ശേഷം ഒരുമിച്ച് ചെയ്യാം. ഇപ്പൊ നിങ്ങൾക്ക് ഈ കൺസെപ്റ്റ് മനസ്സിലാക്കാൻ വേണ്ടിയിട്ട് ഈ രീതിയിൽ പ്രോബ്ലം നമ്മൾ ചെയ്തു പോകും. ഓക്കെ, നമ്മുടെ വേറെ സബ്ജക്റ്റുകൾ അങ്ങനെ ആയിരിക്കത്തില്ല, അപ്പോഴപ്പോഴും തന്നെ നമ്മൾ കൺസെപ്റ്റുമായി ബന്ധപ്പെട്ട പ്രോബ്ലംസ് ചെയ്ത് പോകും. ദിസ് ഇസ് മാത്തമാറ്റിക്സ്, സോ വി ഹാവ് സം ഫ്രീഡം ടു ഡു മോർ പ്രോബ്ലംസ്. ഓക്കെ, താങ്ക് യു.